Here we go.
Get your wizard hats, boys and girls. In this video, I'm going to be showing you the magical art of PID tuning your drone or quadcopter or whatever you want to call it. I've developed a process that, if followed, will systematically tune the P, I, and D values to make sure you get the most locked in quadcopter you've ever flown. Okay, so to start off, we need to go ahead and set up the Tyrannus and all the switches on this so that when we go to beta flight, everything is set up and already working. I'll press the menu button, go in, scroll down to a blank model, hold down enter, create a new model, and then we'll go over to the quadcopter logo, we'll click on that guy, and then we just hit page to accept the channels. So channel 1, channel 2, channel 3, channel 4. Yes, we accept all those. We hold enter to make sure that's all good. All right, now we have model 5. We're gonna go into model 5 by pressing page. I would suggest renaming it PID tune, all right? And then you're gonna set this up for how whatever receiver you have. This is I'm doing for the micro quad, but for you, you might need to do this a little bit differently. But I'm gonna go down all the way, and mine is a D8. Whoops, D8. And then if you haven't bound it, you go ahead and bind it there. You should know how to do that. I'm not gonna go to that right now. So we'll go page over. We'll keep paging until we see the mixer. So channel 5 is gonna be our first auxiliary channel for arming. And then we select enter when it's blinking, then we can hit this switch and that designates this switch to SA. Very good. And we'll go channel 6, will be our second auxiliary channel. And we'll designate that with SB. We'll come out. Our third auxiliary channel is going to be our PID selection. So we're gonna be able to select between P, I, and D with this switch. And I'll explain that when we get to beta flight. All right. And then our last auxiliary channel is gonna be the one we use to edit the values. So I'm just gonna call this one edit. And that's gonna be this RS on the side. All right, so now we've got all of our switches set up with the corresponding correct auxiliary channel. We've got arm, mode, the PID selection, and then the edit switch. Those are all set up properly. And we'll go over to beta flight, plug this in, and set up beta flight so that we can use these switches to modify the PID values in real time while we're flying.
All right, as usual, we're gonna start in Chrome and open up the beta flight app. And we're gonna go ahead and plug in the flight controller. This is an F3 Evo Micro. So we're gonna go over here. And beta flight has been updating very frequently their firmwares, and it's been a very good update every time. So go ahead and just check that you're running the most recent. So for these flight control boards, you're going to use this SP Racing F3 Evo. There are a couple different SP Racing. Make sure you don't use anything else except for the SP Racing F3 Evo. We're going to come in here. We're going to look for the most recent stable version. For me, right now, it's 3.1.3. And then we're going to go down here to load firmware. We'll load that. And then we will flash. And you can see your flashing progress down here in this bar. Once it's done, it'll make some USB noises, and then we can go up into the top right corner and click connect. All right, programming successful. Let's connect. Now it's very important that before going on to any additional tabs that you click save. So on this one, we're going to make sure that we can communicate from the transmitter to the flight control board. So we'll go ahead and turn on the transmitter. And the way...
Switch warning.
Of course. And we're going to be loading up our PID tune model that we worked on earlier. And if you look, the UART3 is where I soldered in the serial connection. So that's how we're going to be communicating. So we'll say save and reboot before we move on to any other tabs. And I'm going to jump straight to ports again to double check that that change did get saved. Okay, so now we should be able to communicate through serial on UART3. We'll go to configuration next. We are using brushed motors. Make sure that's selected. We want motor stop on. This all looks good. Quad X formation, yes. Okay, this is the big deal receiver. We want to make sure and do the S bus and then S bus here. And then VBAT we'll leave alone. Current sensor will turn off. We'll leave that on. We'll do 8 kilohertz for the gyro update, and then we're gonna bump this up from 2 to 4. We want 4 kilohertz for the PID loop frequency. And then we'll turn off black box and transponder. I want to make this CPU load percentage as low as possible. That's why I'm turning off all these things that I'm not going to be using. So we'll go ahead and say save and reboot. We're going to jump to receiver. And you'll see here that our quad is spinning wildly. The channel map needs to be changed to this JR Spectrum Graupner. TAER is the channel format that we want. We'll click save and it should stop spinning, and we should see out here on the left side that our throttle is throttle, yaw, yaw, pitch, pitch, roll, roll. Everything, all the channels are working properly. And then we'll take this opportunity to go ahead and check all of our auxiliary channels. Auxiliary channel 1 here. Yes. So that should be ARM. And then modes should be auxiliary 2. Very good. PID switching. That's auxiliary 3. Auxiliary 4 is our little potentiometer on the side. That works very well. Okay. Perfect. So now we'll go ahead and go to modes, and we're going to say ARM, auxiliary 1 in the middle. Perfect. That's exactly how I want it. Here it's disarmed. It's armed here. That way if I freak out and I hit the switch either way, I go to a disarmed state. But this is armed here. Now if I go into, I don't want to mess with air mode, so we're going to go ahead and say horizon on auxiliary 2. We'll say it starts off in horizon. And then once, and this is important, you have to be able to go into acro mode to actually tune for the PID values. You cannot tune PIDs in a stability mode. So right now we're in stability mode for horizon. Now we're in acro mode. So these last 2 positions I'm just going to leave as acro. And then where we're taking off and stuff, we'll leave that in horizon. And then we should be able to save that. And now, sometimes this is unchecked, and if you don't have any other options on the left side, go this little bitty tab right here, enable expert mode. We want to check that, and then adjustments should be available. Now this is where we do some of the wizardry. We want to enable auxiliary 3, which is this, and we're going to be using this switch to select between the P, I, and D values. And we're going to do that by setting this for the 3 positions of the switch, like that. So we're there, there, and there. So we have 3 distinct positions for the switch. And then whenever this is activated, I want to do pitch, roll, and P adjustment. Pitch, roll, and I adjustment. Pitch, roll, and D adjustment. And we're going to go ahead and do slot 1 for all these. And then we're going to be modifying this via channel 4, this potentiometer on the side right here. So that should allow us to select between P, I, and D, and whatever one we have selected with this switch here, we can then modify, increase, or decrease the value of that P, I, or D with this potentiometer. It's pretty slick. All right, so we're going to go ahead and save that. And just to make sure everything's working, kind of do a sanity check, we're going to go back to this PID tuning tab over here, and we'll see that we'll look at integral, because that's a nice easy number, 40 and 50. So that's the I term of PID, so that's the middle position for the switch, and we're going to go ahead and increase that and just leave that up for a couple seconds. And you'll see this blue light is kind of flickering. That means that the value is being added to. We'll bring this back to its neutral position, and then we'll click refresh and see 5363. So the I value has increased for that. Now if we wanted to increase the D value, we go into our D position and we'd press up, and see again this blue light is kind of flickering, showing that it's adding value, and we'll go back to the detent, which is the neutral position on the switch, and it should stop adding value. So you can see here that those values increased. If you want to decrease the value, again you leave D there and then you bring it down. You'll notice that the blue light flickers a little bit, and then we'll stop, and then notice that this 3537 get decreased to 2426. So as we're flying, we can tune P, then move on to I, and then move on to D. And while it's in the air, we can actually be adjusting, we can be increasing or decreasing those values with this potentiometer inside. This is a pretty slick way. It really makes tuning a lot easier and a lot faster. All right, so what I like to do is go ahead and set your derivative value to 0, your integral, all of them to 0, and your proportional is probably okay to start out at like 40 or so.
Okay, so once the quadcopter is armed and we have it in a non-stabilized mode, so acro mode, we're going to start by focusing on the proportional while the integral and derivative values are set to 0. We're going to set the switch to the P value out of the PI and D, and then we're going to start increasing the P value as we start hovering this. And as we hover, it's going to be kind of slushy and sloppy, and it's not going to feel very good, and that's fine because none of the other variables have any values. But as P gets higher and higher, you'll start to notice a small oscillation, just even hovering, and then they'll start getting really violent. You can kind of hear it now. All right, I stopped it. I've stopped P from increasing. At that point, you want to stop increasing P and start decreasing P, continually trying to hover, and that vibration will eventually go away. And once it's gone, stop decreasing P, and then start giving some really sharp inputs in the pitch and in the roll. And what you'll notice is when it pitches, it's going to pitch and kind of try to vibrate and come back. And you want it to be able to dampen eventually. So after a couple vibrations, you want it to kind of settle out. And if it goes and then just kind of vibrates for a really long time, you want to keep decreasing P. Also, if it pitches forward and then it comes back without vibrating at all, you want to increase P. So you want to be on that edge of where it just kind of vibrates just a couple oscillations and then levels out and dampens itself. At that point, you're good with P, and you move on to D. So we're going to go switch all the way to the down position. So we start editing the D value, and we're going to start increasing D. And we're going to be hovering, and as we're hovering, we're going to be trying those same sharp pitch movements, and we want those oscillations to completely go away. Eventually, what you'll get is, with D going up, you'll notice that you'll pitch, and it's just going to like go and lock. You can stop adding D. And if you want to, you can tweak that a little bit, but D is pretty easy to find because it's very noticeable whenever you stop getting those oscillations. Use your ears too. It's easier to actually hear the oscillations than to see them. Now that P and D are set, we're going to move to I. So that's the middle position for the switch. And then the way that I like to do this is we increase I with this potentiometer on the side, and we continue to increase it. And what you're going to notice is as you're hovering, you give some small inputs forward and backward. And as it's hovering, it's going to try to, like, on its own, without you giving any inputs, it'll drift. The angle will drift on its own, and the more I you give, the more it's gonna tighten that up, and it won't drift. So eventually, it'll stop being like really sloppy, and just kind of the angle is gonna stop drifting, and it'll be very crisp. And you're gonna give it an input, and the angle will hold right where it is. And then if you get too much I, then you're gonna start getting those crazy oscillations back, and it'll just be hovering, and it'll start getting those oscillations. So if you get oscillations, bring I down, and if you're getting the little drifts when you give a little bit of input and the nose wants to come up or whatever, then you need to give more I and bring I up.
Okay, now that we've got the P and I and D values all modified and the quadcopter is behaving just how we want it to, we're going to go ahead, leaving the battery pack plugged in. Make sure and never unplug the battery from the quad during this tuning, otherwise you risk losing the modified values because they haven't been saved to the EEPROM. Now, if you want to unplug the battery, you can take both of the sticks on your controller, pull them close together and then all the way down, and that should save the values to the EEPROM. But I've had some issues with that where sometimes it didn't work, and the best bet is just to leave the battery plugged in all the way up until the point where you're done, then plug it into the USB, and then look at the values in Betaflight, and then you can click save, and that'll write to the EEPROM, and you don't have to worry about missing any of the values up. So, looking at what we got here, we've increased proportional from 40 to 145. That's a pretty big jump. I'm actually going to increase it a little bit more to 150. Whoopsie daisy. To 150 for both the roll and pitch, and then I'll go ahead and just copy that down for the yaw as well. Now, if you're a stickler for getting every little vibration out and just fine-tuning the crap out of this, you can go in and refine the process and modify roll and pitch separately. But for what I'm messing with and what I'm doing, I found that gets me close enough that kills almost all the vibrations. For integral, it went up to 42. Now, just to be careful, visually and looking at it, sometimes you add too much, I've found. So I'm going to bump this back down to 35 from 42, just to make sure that I'm not going to be getting any oscillations when I'm descending or anything. And I'll go ahead and do that for yaw as well. And then derivative, I'm going to bump that up from 37 to 40, and that seems about right. Now, if you look over here on the right side, I've modified the rates. Now, this is just preference for me. You can copy these over and see if they work for you, but I found that it's a pretty good in-between for inside flying and then also ripping around outside. You might want something a little bit more aggressive, but for me, this works well.
So that's the process that I use when I PID tune my quads. Hopefully you learned something in this video, and now you feel like it's less of a mystical art and more of a systematic process you can go through to get a locked-in quad. I've got some exciting news. The micro quad frame that I've been developing is finished. I have a final design. I call it the NB98, and you can buy it on my website, NeatherBot.com. So go check that out. Make sure and also hit the like and subscribe buttons if you want to support my channel. And if you have any questions, put them down in the comments below. Also, go ahead and ring that little notification bell. It lets you know whenever I post new videos. And I will see you next time.